So surds, I'm going to start off by answering the question of what is a surd. Now a surd is a square root that can't be simplified. So for example, root 2 is a surd. However, root 9 is not a surd, so not a surd, as it can be square rooted. Another thing that's important to notice at this point is that surds are irrational numbers. Now, irrational numbers are numbers that cannot be written in the form a over b, where a and b are both integers. So root 2 therefore cannot be written as a fraction. Some examples of other irrational numbers, so pi is another irrational number, the natural number e is another irrational number, and then quite a lot of the surds, so root 2, root 3, etc., etc., etc. Examples of rational numbers then, so these are numbers that can be written as fractions. So we can start off with any type of fraction, obviously, so 2/3 is rational. If you had the number 0.11111 and it carries on, that's also rational because it could be written as 1 over 9. So basically any number that can be written as a fraction is a rational number. Now what we're going to look at to start with is simplifying surds. So I've got 5 examples here that we'll just have a run through. So for the first one, we can simplify a surd by breaking it down into simpler terms effectively. Now, one of the things that we can do with surds is if we've got root 18, then we can split this up into a root times another root, where these two numbers multiply to give 18. So basically, if we had the square root of a and we multiplied it by the square root of b, that would give you the square root of ab. So the two numbers times together. So for the square root of 18, we can split this into two numbers. Now to make it something that we can simplify, one of these numbers needs to be a square number. So I typically use the first one. So this needs to be a square number, because if it's a square number, it means that we can square root it. Now, square numbers that will be of use, so 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are the first 10, excluding the first one, because 1 squared won't help us in these situations. So in terms of the number 18, we can write this as 9 times 2. Now, the square root of 9 is equal to 3. So we can write this as 3 times root 2, which, like in algebra, we'll write next to each other just as 3 root 2. Do the same for the second one, so root 20. Again, we're looking for a square number, so if I did root 4 times 5, so 4 5s are 20, then this will give me 2 root 5. With C, I've got root 48. Now for this one here, different ways you can approach it. So the easiest way to do it is to look for the largest square number. So the largest square number that goes into 48 is 16, so that'd be 16 times 3, which gives you 4 root 3. If you can't find a large enough square number, you can do this in more than one step, so I'll show that underneath. So you could do this, if you couldn't find 16 and you thought, well, 4 goes into it, you could do root 4 times root 12. Now that would be equal to 2 root 12. However, root 12 isn't simplified, so we can simplify that further. So 2 root 12 is the same as 2 times, and then root 12 is root 4 times root 3. Now root 4 is 2, so we end up with 2 times root 3, which is 4 root 3, which is the same answer as the one we got above. So you can do it in one step by looking for the largest square number, or you can do it in multiple steps and just do repeated simplifications. Either way will get you the same answer, so it doesn't really matter which way you do it. So for D, then we've got root 72, so root 72 is root 36 times root 2, so 6 root 2. And then finally for E, we've got root 700, which is root 100 times root 7, so 10 root 7. So that's simplifying surds. We're now going to move on to having a look at adding and subtracting. So again, 5 examples here to have a look at. So if we look at the first one, so 2 root 3 plus 3 root 3, the way we add surds is very much like how we work with algebra. So if this was algebraic, you might have 2a plus 3a, because the root 3's are the same. Now 2a plus 3a is equal to 5a, and the same idea applies here. So we've got 2 root 3 plus 3 root 3, that means that we've got 5 root 3's altogether. Subtraction is exactly the same idea, so 8 root 5 minus 5 root 5, we've got 8 of them, we're taking away 5 of them, therefore I have 3 of them left. Part C and onwards, we're going to need to use the simplification that we've just done to work out our answer. So for C, and I'm going to move this down here and start to work below. For C, so I've got root 300 plus root 27. So root 300 is the same as root 100 times root 3, which is 10 root 3. Now we can use this to help us with the second one. So if we're not too sure about root 27, we could say, well, if it's going to simplify, then it needs to involve this root 3. And then what do we multiply 3 by to get 27? That would be 9. Therefore, I've got another 3 root 3. If I add them together, it gives me 13 root 3. For D, the same idea. So we've got root 18, which is root 9 times root 2, which is 3 root 2. And to this, we're going to add root 8. Now, root 8 would be root 4 times root 2. So we're going to be adding another 2 root 2. So that makes that one equal to 5 root 2. Finally, for E, now we're going to use what we already know. So root 8 is root 4 times root 2, so 2 root 2. Now they're all going to have to involve root 2, so otherwise it won't simplify. So root 98 must be 49 times 2, which is 7 root 2, and then root 50 must be 25 times 2, so we're going to be subtracting 5 root 2. Now 2 plus 7 is 9, take away the 5 is 4, so we're left with 4 root 2. The next part we're going to have a look at is expanding surds. So what happens when we have brackets involved? Now very much like algebra, we would apply the same ideas. So for A, if I've got root 5 times 3 minus root 5, I'm going to do root 5 times 3, which will be 3 root 5. And then I'm going to take away root 5 times root 5. So root 5 times root 5 is root 25. So 5 times 5 is 25, which simplifies to 3 root 5 minus 5, because square root of 25 is 5. For B, so I've got 2 plus root 3 multiplied by 6 minus root 3. So again, same idea. So 2 times 6 is 12. Take away 2 root 3. Plus 6 root 3 minus root 9. Now root 9 is 3, so 12 take away 3 is 9. Minus 2 root 3 plus 6 root 3 would be plus 4 root 3, so minus 2 plus 6 is 4. And then for C, I've got 1 minus root 7 squared, which will be 1 minus root 7 times 1 minus root 7. So 1 times 1 is 1, minus root 7, minus root 7, and then plus root 49. So minus times a minus is plus. So 1 plus 7, because root 49 is 7, would be 8. And then we've got 2 root 7s that we're taking away. So that's how we expand. We're going to be able to use this in the next part where we're rationalizing. So in terms of rationalizing, all that means is making sure the denominator is a rational number. Now the way that we do that, so if I look at the first one here, so we've got 5 divided by root 2. So we're going to use the idea of equivalent fractions. So if the denominator is root 2, so it's 5 over root 2, we're going to multiply this fraction by root 2 over root 2. Now the reason why we're going to do that is because it's going to maintain the equality of the fraction, because what we're effectively doing is multiplying by 1, because root 2 divided by root 2 is 1. We're just manipulating it so it looks like it's in a different form. Now, if we do this multiplication, so when we multiply fractions, we just multiply across. If we do 5 times root 2, we get 5 root 2. And then root 2 times root 2 is root 4. Now, root 4 simplifies, so we get 5 root 2 over 2. Same idea applies for b, so we would do 12 over root 5 times root 5 over root 5, which will give us 12 root 5 over root 25, which would be 5. Now for c, there's different ways you can approach this one. So 8 divided by 3 root 2, you could either multiply the top and bottom by 3 root 2, or it's actually simpler to multiply it by root 2, because we're trying to rationalize it, so we just need to remove the surd. Multiplying it by 3 root 2 wouldn't give you an incorrect answer, it would just give you a larger equivalent answer. So the top here then would be 8 root 2, and then the bottom would be 3, and then we've got root 2 times root 2, which would be root 4. So if we simplify that, that gives us 8 root 2 over, now the square root of 4 is 2, 3 times 2 is 6. We could simplify this further, so divide top and bottom by 2 to get 4 root 2 over 3, and that would be the fraction in its simplest form. Just to show you, the same thing would have happened if we did times 3 root 2, so I'll do that just below. So 3 root 2, so if we multiply the top by 3 root 2 and the bottom by 3 root 2, we would get on the top 24 root 2, on the bottom we would get 9 root 4, which would give us 24 root 2 over, so root 4 is 2, 2 9s are 18, and then if we divide top and bottom by 6, we would get 4 root 2 over 3, so we would get the same answer. It's just one way is a little bit simpler perhaps, but you can get the same either way. Now finally for D, we've got root 2 plus 1 over root 2 plus 2. So I'm going to do that one at the side here. So for root 2 plus 1 over root 2 plus 2, what we need to do here is use the difference of two squares to be able to rationalize the bottom here. So what we're going to be multiplying by this time is the denominator, but with a different sign in the middle. So root 2 minus 2 in this case. The reason why we do that is because with the difference of two squares, we ultimately are going to end up with this value squared, take away this value squared. If we were to multiply by root 2 plus 2, we'd end up with a number of root 2's in the middle, so it wouldn't actually rationalize the bottom at all. So if we were to do this, this leaves us with two sets of brackets that we're going to need to expand. So this is equal to root 2 plus 1 times root 2 minus 2 divided by root 2 plus 2 times root 2 minus 2. So we can expand both of these. I'm just going to move down slightly, maybe just box off what we've already done. So on the top then, if I was to expand that, I would get root 4, so root 2 times root 2, minus 2 root 2, plus root 2, minus 2, and on the bottom I would get root 4, minus 2 root 2, plus 2 root 2, minus 4. So as you can see, these in the middle, our root 2's here are going to cancel. That's why we're going to end up with a rational denominator. So if I simplify the top then, I have 2 minus 2 is 0. And I've got minus 2 root 2 plus root 2, so I'm going to have negative root 2 on the top. So again, this value here was 2, so 2 minus 2 is 0, minus 2 root 2 plus root 2 is minus 1 root 2, which we'd write like this. And then our denominator, so we've got 2 minus 4, so that's minus 2. And then we've got minus 2 root 2 plus 2 root 2, which cancels. Now, we've got a negative over a negative here, so that's the same as just root 2 over 2. So that is that complex, perhaps looking fraction rationalized. Now I'm going to apply this to 3 exam questions just so you can see how this can be applied in terms of a problem. So the first one here is we have a trapezium, and it says all measurements shown are in centimeters. It says work out the area of the trapezium, give your answer in centimeters squared in the form a root 5 plus b, where a and b are integers, remembering that integers means whole numbers. Now what we're going to be using here is the area of the trapezium, so we know that's a half a plus b times the height, where a and b are the parallel sides, h is the perpendicular height of the trapezium. So in this case then the area will be equal to a half of root 5 plus root 5 plus 6 times the height, which is root 5 minus 2. So that gives us a half of 2 root 5 plus 6 times root 5 minus 2. Now before I expand these brackets, I'm going to deal with the half first of all. So if I multiply a half into the first bracket, that leaves me with root 5 plus 3 times root 5 minus 2, and then I can expand this to get our solution in terms of the area. So if I was to do root 5 times root 5, so that gives me root 25. Take away 2 root 5 plus 3 root 5 minus 6. Now we've got 5 minus 6, so that's going to be minus 1. Minus 2 root 5 plus 3 root 5 would be plus 1 root 5, so just root 5. Therefore the area is root 5 minus 1, so where a is 1 and b is minus 1. Now for the second exam question, we have this one here, it looks reasonably complex. So we've got ABD as a right angled triangle, so that's this big one on the outside. It says all measurements are given in centimeters. C is the point on BD such that CD is root 3 over 3. It says AD is equal to BD, which is root 2 over 2. So this length here is root 2 over 2. That says work out the exact area in centimeters squared of the shaded regions. That's this part here. Now to work out the shaded region, we're going to need to do the larger triangle, take away the smaller triangle, and that will leave us with the bit that's in between them. So for the larger triangle, so for split this up as, so we're looking for the area of ABD. So for the area of ABD, we're going to use a half times the base times the height. So just multiplying across, we've got root 2 times root 2, which is root 4, so that's 2, over 2 times 2 times 2, so 2 times 2 is 4, times 2 is 8, so that simplifies to a quarter. So that's the area of the larger triangle. Now for the smaller triangle, so ACD, so the area of ACD is going to be a half times the base, which is root 2 over 2, times the height, which is root 3 over 3. So again, multiplying across, so we've got root 2 times root 3, that's root 6, can't simplify that. And then we've got 2 times 2 times 3, so 2 2s are 4, times 3 is 12. So nothing we can do with this one at the moment. Now the shaded area then is going to be the difference between these two. As I say, it's the larger triangle, take away the smaller triangle. So the shaded area will be a quarter minus root 6 over 12. Now we can leave it in that form. If we wanted to do so, we could combine them to make it one fraction. So multiplying the first one top and bottom by 3. So we could write 3 minus root 6 over 12, which would give us the same answer. However, it's looking for the exact area in centimetres squared, so both of these would be sufficient. Now onto the final exam question. So this one here, we've got a triangle DEF, so it's this one here in the middle, so DEF, and it's inside a rectangle ABCD, so it's right, the large one around the outside. Now it says, show that the area of triangle DEF is 8 centimetres squared, you must show all your working. Now, the easiest way to do this, because we can't, without any level of complexity, work out the area of the triangle directly, so we don't know any angles, we could work out the perpendicular height, but it'd be very complex to do. The easiest way to do it is to do the rectangle around the outside and then take away these 3 triangles. However, to do that, we'd need to know the dimensions of the rectangle. At the moment, we know that the width of it is 4, but we don't know the length. However, we could work that out using Pythagoras. So we know that this is 2, and we know that this is 2 root 10, and we know that this is a right angle, so we could work out this length here. So using Pythagoras, I'm going to use that to work out CD. So using so a squared plus b squared equals c squared, that means we've got 2 squared plus cd squared will be equal to 2 root 10 squared. Now it's important we put this in brackets because all of this is squared, not just the root 10. So careful about how we set this out, which means that cd squared is going to be 2 root 10 squared, take away 2 squared. Now if we work that out, 2 root 10 squared is 2 squared, which is 4, times root 10 squared, so root 10 times root 10, which is root 100. So we've got 4 root 100, take away 2 squared, which is 4. Now the square root of 100 is 10, so 4 times 10 is 40, so 40 minus 4, which is 36. Now if CD squared is 36, that means that CD is the square root of 36, which is 6. Now if I label that on my diagram, that means that this length here is 6 centimetres. Now we can use that to help us with the triangle in the middle. So we know that the whole rectangle, so the rectangle is going to be 6 times 4, which is 24 centimetres squared. And now from that we can take away these triangles. So we know that this is 4, we know if the whole thing is 6 that this is 4. So if we look at triangle CDF, that's going to be a half times the base, which is 6, times the height, which is 2. Half of 6 is 3, 3 times 2 is 6. If we look at this little one down here, so BEF, that's going to be a half times 2 times 2. A half of 2 is 1, times 2 is 2, so 2 centimetres squared. And then finally, triangle ADE is going to be a half times 4 times 4. Now, a half of 4 is 2. 2 times 4 is 8, so that would be 8 centimetres squared. So that means that triangle DEF is going to be 24 minus 6 minus 2 minus 8, which equals 24 minus 6 is 18, minus 2 is 16, minus 8 is 8. So it's 8 centimetres squared.